Welcome back to Applied Algebra and Trigonometry. Today we're going to be talking about using your TI-89 calculator to do graphs from tables. Here is our first example. Steam in a boiler was heated to 150 degrees Celsius and then allowed to cool. Its temperature in degrees Celsius was recorded each minute. So here we have the time in minutes and the temperature in degrees Celsius. Each vertical pair here corresponds to a horizontal pair in the table on your calculator, and it corresponds to a point on the graph on your calculator. And every pair expresses what the dependent value is for a given value of the independent variable. For example, at the time t equals 2 minutes, the temperature is 138.5 degrees Celsius, whether you look at it in the table as I first indicated, or on this chart, or here on the graph. Let's ask the question though, what would the temperature be after 2.5 minutes? 2.5 minutes is not on this chart. What would the temperature be? I am going to teach you a mathematical method for approximating the answer to that question. When faced with a situation, you could take a basic average, take half of it, because 2.5 is halfway between the two. Or if you had a graph on which the y-axis were better marked, you could just read off an approximate value. However, I would like to teach you a method that works both when you're not exactly halfway between the two, and when you have a graph that is difficult to read, as long as you have the coordinates of some points on the graph, and will work to give you an approximation when you don't have a smooth curve like we have here. This method is called linear interpolation. This method makes the assumption that the difference between the independent variable values is proportional to the difference between the dependent variable values. To use this method, we only need to concentrate on the variable values that are immediately less than and greater than the values in which we're interested. Instead of using a question mark for the unknown value, I'm going to use a capital T to stand for temperature. My first step is to determine the difference between the value we're interested in the independent variable, and either the value in the chart that is below it or above it. And once I choose whether I'm using below or above, I'm going to do the same for the independent variable. In this case, the difference between the value lower than it and 2.5 is 0.5. But what is the difference between 138.5 degrees Celsius and the temperature for which we are looking? Let's assign the variable x to that value since we don't know yet. Now we need to determine the differences between the values above and below our target. Here, for the time, the difference is 1.0, remembering those are minutes. And down here when we're talking about the temperature is actually not going up. Look, it's going down. It goes down 3.3 degrees. So let's write out our proportion. We're going to be forming each ratio in this proportion by putting the part of the difference over the whole difference. Let me be more specific. For this section of the chart, the whole difference is 1.0 minutes, and the part for this section of the chart of the time difference is 0.5. And likewise for the temperature, the whole difference of this section of the chart is minus 3.3 degrees Celsius, and the part is x. We don't know the difference there yet. We're going to determine it. And now that I have a proportion set up here with actual numbers, I can get rid of this part in whole. And now I'm going to solve for x by cross multiplying. 0.5 times negative 3.3 equals 1.0x, which is just x equals whatever this turns out to be. And what it turns out to be is negative 1.65. All right, so are we done? Actually, no. We have found x, but that's just this value. We have not yet found our temperature. Now I simply need to take the value from which we were measuring the difference and add our x value. In this case, we're adding a negative, so it becomes a subtraction problem. Our final answer is 136.85 degrees. That is equal to T. So after 2.5 minutes, we would expect the temperature to have decreased to 136.85 degrees. For our next example, let's look at this chart that records the lift in millimeters of a cam. As the cam rotates, it lifts and lowers the piston. The top line of the chart indicates the angle through which the cam has rotated from its starting position. The next line records the lift in millimeters. That indicates the height of the cam from its original position. Our challenge is to find the angle that corresponds to a lift of 3.0 millimeters. So that would put it about here, between 3.3 and 3.8. That means the angle is going to be between 60 degrees and 80 degrees. We are looking for the angle that corresponds to 3.0 millimeters, so I'm going to call that angle A. And how far is that from 40 degrees? We don't know. Let's call that x for now. We're going to discover what x is. The difference between 2.3 and 3.0 millimeters is 0.7 millimeters. The difference between 2.3 millimeters and 3.3 millimeters is 1.0 millimeters. And the difference between 40 degrees and 60 degrees is 20 degrees. All right, now we can set up our proportion. Remembering that each ratio in our proportion consists of the part. So I'm going to put the part in the numerator over here. I'm going to put the part in the numerator over here, and the whole in the denominator on the left, and the whole in the denominator on the right. And again, we wind up with 1.0 x. I promise you, it does not always come out to be 1 there. Equals 20 times 0.7. So x equals 14. So now we take 40 and add our 14 to it to get 54 degrees. That is the angle that corresponds to a lift of 3.0 millimeters for this cam. As you can see from the graph of this data, the distance from the wall to the water changes as you travel along the wall. Now, the graph here looks kind of like a smooth curve doing some things, but the picture I drew of the wall and the water line actually fits that data pretty closely. And as you can see, they vary. So we're not going to be able to get an exact answer between any 2 points on this graph. It will truly be a linear interpolation, an approximation. So let me ask you, at 43 feet along the wall, what is the distance from the wall to the water line? And h is my variable for H2O. Between 40 and 43 feet, there's obviously 3 feet. And between 40 and 60, there is 20 feet. At the bottom here, between 56 and h feet, we do not know how many feet there are. We're going to figure that out though. And between 56 and 33 feet. Now, in this case, in the case of capital D, I was taking 60 and subtracting 40. So I'm going to take in the same direction, 33 minus 56, which gives me negative 23. Let me write negative 23 here in my diagram so I do not forget where it goes, and that will help me know where it goes in the proportion. For the distance along the retaining wall, I'm going to write down a ratio of 3 over 20, the part over the whole. And then for my distance from the wall to the water, I have x over negative 23. If I cross multiply and solve, I get x equals negative 3.45. That is the value for x, so let me write that in. So for our final step, we take 56 and we add negative 3.45 to it to get 52.55 feet. And that is the distance from the wall to the water line when we have moved along the wall 43 feet. Now I am going to give you some data for you to try. I'll give you a few examples. So I'd like for you to pause the video now and graph this using your calculator. The correct graph will be available during class. Here is a second data set for you to work with. Please graph it and then answer the question, at what wind speed does the temperature feel like? And do that for the 3 instances I have there. 6 degrees Fahrenheit, 0 degrees Fahrenheit, and 10 degrees Fahrenheit. Here's a hint. You're going to have to interpolate for one of them. Here is another example for you to graph, and when you are done graphing it, please determine at what frequency this engine produces a torque of 37 foot-pounds. Let me end this video with an admonition to make sure you are using the data matrix tool on your calculator and not the table or something else. This is where you need to start. Please let me know if you have questions, and I will see you in class.